Okay, I decided to do a video over again for our class because there was so much lagging that the video actually is pretty broken up. So I'm just going to record the class again, and that way it's a little bit shorter too. So there was points when I was trying to get the Excel file to load, took a long time, and points when I was trying to get the SitLearn system to work, and that was also lagging. So I'm going to try to do the recording again now. So this week's class, so we're in the week of March 30 through April 3rd. This week's class, if you want to find the content, go to course modules, scroll down till you get to week 11 here, lesson 11, module 11. You'll notice it's related to chapter 6. There's 2 parts to chapter 6, which is the second part next week. For this week, there was the meeting, so this recording, if you're watching it or if you attended the meeting, and then you have the Excel homework, which is going to be due Thursday night, and then Team 6 has to create a Zoom presentation of big data companies 34 through 39. So let me take you in. So if you click on this link, it shows you, let me go to student view so it looks like what you see. Okay, go back in. So this is what it looks like from your side. There's the learning objectives for the week. So creating a random sample, calculating the sample statistics, determining the sample distribution, which is really just the standard error of the mean, and calculating a 95% confidence interval. So here's the slides that I'm going to upload here in a second and share with you. And then here's the template for the homework assignment that you're going to complete. And then, of course, Team 6, you have your link for your presentation. So over here on the side, you'll see this is this link we're on right now. This is chapter 6 homework. So if you click that, you'll see the due date is Thursday at midnight. If you want to see how I'm grading it, there's the rubric. So sometimes students miss this file management piece where I'm looking for you to rename the file, save it on the first tab, and making sure that I can open your file. So I'm double checking and making sure the preview works. Okay, so if you want to see that, just view the rubric. And then this is where you click to upload your homework assignment. Okay, then these are the video lessons for the homework. So there's roughly 1 for each tab of the homework assignment. So you can watch those, you get a little hand with that. Okay, so other than that, that's all you got. So this class, either watch the video or come to class. The homework assignment, which is due Thursday night at midnight, and if you're Team 6, you'll see an extra link down here for Team 6 where you have to upload your Zoom presentation. So you're going to record yourself just like I am right now, and you'll have all your team members do part of the presentation with maybe a deck of slides, and then you'll upload that presentation. Okay. So the link to this recording you probably found here or in my email message that I'm sending, but I'll always keep under this link all of our Zoom classes. So I'll upload this file after I get the recording done. All right, let me go over and share my PowerPoint slides. Okay, and I also want to open our homework. Okay, I'm ready. All right. So like I said, we're looking at chapter 6. This is statistical inference, where we're looking at creating a sample. So let me talk about that a little bit more. When we're collecting data, we usually want to know something about the characteristics. So for instance, it's mean, standard deviation, variance, number of items, right? So there's a bunch of different things that we generally want to look at for descriptive statistics from a population of data that we're looking at. So sometimes the population of data is huge. And I'll give you an example. When I did my thesis, I looked at a sample, a pilot period, where the stock market was transitioning from manually operated, sort of. I mean, it was still electronic, but not It was digitized, but it wasn't electronic trading. And they transitioned to markets so that people could trade on these electronic markets. So you don't need a specialist, in other words, to trade. You can trade on your own, even as a broker or as an individual. So the data set that I was working with was hundreds of millions of lines long. It's huge. And I had to partition that data and create little sub-samples of it just to be able to work with it. In fact, I had to hire somebody to help me who had a larger computer than I did because I couldn't run the data sets on the machine that I had. It needed a much, much bigger server to be able to do it. So that's one of the reasons why you want to partition data or take a sample out of data, right? So it's time consuming, right? When you have large data sets, it's sometimes not necessary to use that much data. You can extract a sample and get a reasonable approximation of what that population looks like. And sometimes it's not practical. Like I said, I could not get that big sample to run on my machine. So we had to carve it down into smaller pieces. And I still had to get help with using a bigger machine with a friend of mine. So we do, to overcome these difficulties, we create those samples, and then we make inferences about the population of data. Okay, so we create a sample, we run the statistics, and then we can calculate a confidence interval. So this is where we're going today. A confidence interval that says certain percent, so let's say 95% of the time, I can use this interval and predict that the average score or the average amount will be within that range 95% of the time. So it gives us a feeling of confidence about our sample relative to the population. Okay, so the first thing you got to do is figure out how to select a sample. The second thing is then to calculate those point estimates. So that would be things like the mean or the standard deviation or the number of values or the proportion of values, things of that nature. And then we'll do what's called the standard error, which is the sampling distribution stuff. And this will help me to build these intervals, the confidence intervals, for me to use to evaluate the values in my sample. So I can say, I will expect that the values, these point estimates, will be within this range 95% of the time. So when I teach you how to do the confidence intervals, I'm going to be doing 95% confidence intervals. All right, so that's where we're headed. Let's first get this whole idea of creating a sample down. There's two types. There's finite population and infinite population. You're going to see formulas for these are fairly simple to use. In fact, we're going to use the one for the infinite population, even though most of the times we're dealing with a finite population. So let me show you what those look like. Here's the definition first for a simple random sample. So it would be of a certain size. We're going to look at a data set for your homework that has 2,500 lines in it, and it's employees data. And we're going to create a sample for class that's 30 employees large. And then for homework, you're going to do the same thing. Yours is going to be 50 employees, so a sample of 50. So it takes a portion of the population that you have. Okay, so that's how you do that. Then another type of sample is called an infinite, where you have an infinite population, a population that is very large and keeps building, right? Keeps going. So examples, if you look at stock market data, every day we're adding new data points. And so it just keeps growing and growing and growing. And it's a very large sample. And so we tend to look at fairly large stretches of time, but we also look at isolated periods. And we have to be careful because you know that there is cycles in these things, right? Waves of crashes and booms. So Boston booms that we have to be careful of. So we're going to look at these formulas now for calculating a sample in Excel. We're going to use the RAND function. We'll start with that. So I'll help you build the sample, and then we'll come back and get the formulas for getting the point estimates. So let's do that. Okay, so remember when you do this homework assignment, this is the same, I buried them together. So I'm doing my in-class stuff inside your homework stuff, so you've got one file to work with. instead of 2. So remember to save this using your first and last name in the title with the description of whatever this message. Chapter 6, part 1 is fine. And make sure you save it on this tab so when I open it, so you just save it at this point right here, and that'll open at that point when I grade your file. All right, so here we go. This is completed, but let me do this. Let me take these columns, kind of start over so you can see what I'm doing. Okay, so I took that, and then let me get rid of this column entirely and start over. Okay, so what we're doing, we have this sample. It's got 2,500 lines. So if you scroll all the way down, you get down to about 2,501 because we start at 2. It's a group of employees. This is the manager number for that employee. This is their annual salary. And this is whether or not they participated in a training program. And so we've got some quantitative data, right? And we have some qualitative data, meaning categorical data. All right, so that lends itself really well to doing what we want to do and to show you how to work with both types of data sets, which is cool. So we want to pick, I'm going to have you pick 30. For your homework, you're going to pick 50. So we want to pick 30 employees out of the sample. I don't want to just take the first 30 because that wouldn't be really a random generation, random pick. You want to think of it like this, like you're taking each one of these and you put them on a piece of paper. So this person right here is on a piece of paper and a hat. And this person right here is on a piece of paper and a hat. And you're drawing out in random these different pieces of paper. So there's a real simple way in Excel for us to do that. So we're going to assign each one of these a random number. And we do that by using this rand, open parentheses, close parentheses function. So type that into the first cell, hit enter. That's a random number. And then if you want to copy that down to the bottom, there's a shortcut. Just click right there. And that copies the random number all the way down. All right, so now what you can do to kind of scramble the data is you can say, okay, I want to sort that whole thing based on the smallest random numbers. You could do the largest either. It doesn't matter. Just go one way or the other. But it doesn't matter. You could do it either way. Problem is that because we're using this rand function inside these cells right now, that if we scramble this, it'll actually recalculate the random numbers. So we don't want it to do that. We want it to stay fixed on those numbers. So what you can do, keep it highlighted like this. So if you don't have it highlighted, click the first cell, double click here, and it'll highlight everything. It just changed all my numbers, but that's okay. They're just randomly generated numbers. We don't care what they are, okay? In fact, we don't want to know like what they are. We just want a random bunch of numbers, and then we're going to sort them. So now you go to copy that, and then go to paste, and then pick paste values. So what ends up happening there is that each one of these cells now contains the value as opposed to containing the function that we previously had there. And now I can sort. So highlight that whole thing like that. Then hit Control-Shift down arrow, Control-Shift down arrow. That highlights the entire population. See how it dropped all the way down to 2,501. So it's highlighting the whole population. And now I want to sort that data. So go to Data, Sort, Sort by. Okay, it does have headers. So that's clicked. That's okay. Just be careful of that. And then you want to sort it by the random number. And smallest to largest. Or you can do large to small. It doesn't matter as long as you do one or the other. All right, so it just randomized. It just sorted these random numbers, smallest to largest. And I want to do a sample of 30. So I'm going to grab, I'm going to grab the first 30. So that takes me down to 31 because we started on 2. So I go home, I copy that. There's a random sample. All right, that's how you go about doing that. All right, so you're going to do a 50, but you do the exact same process. The only thing you do different is at the end, instead of highlighting down to 31, you would highlight down to 51 and copy that over. And then that will be the sample that you'll use all the way through this entire exercise. Okay, let's go back to the slides. Okay, on to the next thing. So point estimation. All right, so we're going to do a sample mean on that 30-point group that we just did. We'll do a standard deviation and use the .s function, or don't leave it off. So just put the .s that indicates it's a sample. Okay, so that's the standard deviation for a sample. Okay, and then we're also going to look at that categorical variable, that yes and no, and calculate the percentage of people that did participate. So percentage of people that we say yes went to the training program, the portion that participated in the training program. So that's what we're going to do for this next part. So calculating the sample mean, the sample standard deviation, the sample proportion is called point estimation. So you know how that is. Sometimes we really end up doing the same thing we've done before, but we just have a different name for it when it's in a different context. And so that's what we're saying here, that the sample mean is the point estimator for the population mean. The sample standard deviation is the point estimator of the population standard deviation. The sample proportion is the point estimator for the population. So all of those variables is called a point estimate. Okay, so let's go back and we'll do those three things, real simple, and I'll show you how to use the functions in Excel. Okay, so we're going to take the average of the annual salary. So right up here equals average, and highlight the annual salary. Okay, so I'm going to insert a column there so I can give it a nice label. So this is the mean, X, right? So X being the representative notation for sample mean. Let's do the standard deviation. So standard deviation for a sample. That's S, indicated by S, so let's add that, comma, S, there we go, equals standard dev dot S, that's the one we want right there. Highlight that. There we go. Okay, then we're looking at this training program. We want to know how many people said yes. So we're going to do the count. So equals count if, open parentheses, highlight this range, then hit comma, space, quotes, yes, end quotes, close it up. All right, so 19 of those employees in that sample of 30 said yes. And so now this is the proportion, P, out of 30, because my sample is 30. So it's 19 divided by 30. Okay, 19 divided by 30. Of course, yours is going to be a 50, so you'll be counting the yeses and dividing by 50 to get this. Okay, so that's actually telling us that 63% of the employees in this population said yes. Okay, that's all you have to do to get the point estimates done. Okay, let me go back and keep going. Okay, sample distributions. So what we're doing here, let me explain, is we want to know those point estimates that we just did. We want to know if they're representative of the population, because it's just one sample. So one of the things we could do is we could do about 500 different samples of 30 or 50 you're going to do for homework, and then get the average of all of those and see where that stands. But heck, we might as well have just done the whole population if we're going to go to that much trouble, right? We're trying to save some time. So it's kind of like a shortcut that we're going to talk about here. So what we calculate is something called the standard mean. And what that formula does for us is it gives us like a margin of error that we should expect given the size of our sample and given the confidence interval that we're looking for. So for instance, we could do a 90% confidence interval, we could do a 95, we could do a 99. For our example, we're going to do 95%. So that means we have a 5% significance level. And we're going to use that statistic to give us some feedback on what we should expect for a mean if we were to run this sample a whole bunch of times, where we'd expect that mean to fall, or where we'd expect that proportion of yeses to fall. And we're going to do both, the mean salary and the proportion of yeses. So that's what this part's about, right? So like I said, in the previous section, we took one simple random sample of 30 employees from a database of 2,500. We calculated the mean, the standard deviation, and the sample proportion. Suppose we select another random sample and obtain a different point estimate. In fact, we create 500 different simple random samples with 500 different data points. Then we'd have enough data to be able to say with some certainty that we would expect the average to be this amount. But like I said, why would we bother doing that? Why wouldn't we just spend the time looking at the entire population or a bigger sample? So this is, again, a shortcut for you to be able to run one sample and then run this statistic. It's called the standard error. Run this statistic and then use that to build a confidence interval that'll help you to gauge where that number should be if you did it a whole bunch of times. Okay, so we have the one, like I said, for the mean. We're going to do one for that, right? So we'll have a standard error for the mean, and we're going to call that X bar, sampling distribution of the mean, expected value of the mean. And we're going to use that same one to extrapolate the standard error. So let's keep going. Here's the formula that we're going to use right here. You know, it says infinite. Let me explain. So there's different formula for the two types of populations. The one we're working with right now is finite population. It has 2,500 employees, and that's it. Right, the finite population. The extra, so if you look at this versus this, the extra is the square root of this thing. And honestly, this starts to gravitate towards 1. So you're taking 1 times the same thing here, and they become very similar. So we end up just using this formula to get our standard error, which helps us calculate the confidence interval. Okay, so we're going to take this baby steps. We need this first, and then we need a t-stat. And then once we get the t-stat, we can get the confidence interval. And thankfully in Excel, there's a shortcut that helps us get both, right, real quick. All right, so as I said, this thing that's in the finite population, correction factor, it gets really close to 1, and you're multiplying there, right? See, multiply this by this. So anything multiplied by 1 is itself, so we just use that other formula, just use this formula as the standard error, okay? As long as you've got population size, which we have 30, and the one I just built, you're going to do one that's 50, so it's even better. As the standard error will decline. Now the margin of error declines as you get a bigger sample size. So as you use a different sample size, if they get bigger, you collect more data, and you use more data to get your statistics, then the standard error will go down. So let's stop right there and go practice that. Use that little formula that I gave you to do that exercise. Okay. So to get the standard error for this thing here, we've got to take S, right? So that's S. And we divide by the square root of whatever sample size we're using, which in my example is 30. Okay, so that would be what we call the standard error, is what we call it. And it's an estimate that we're going to use for the next part. So I want to take it in baby steps. So this is going to be used to help us get a confidence interval that we can then add and subtract from this, so that then we can say that we expect within 95% of the time, the value of X, the mean value, will fall within this range, okay? Fall within that range. And we can be confident, that's why it's called confidence interval. Be confident 95% of the values will be within that space. Okay, so taking this one step at a time, let's break right there and go back and get the other piece. Okay, so then we have to do P as well. So remember what P was. I threw the formula back in here. It's the number of yeses, X representing the characteristic we're after, the number of yeses out of the total sample, which we had 30 in the sample. So whatever proportion of the sample P on P. And we can also get, right here is the one we're going to use, same thing, this thing falls to 1. So we're just going to use this. We're just going to use this as our calculation. First part, there's a couple parts to do here. First part of getting the margin of error is what we're going to call it, margin of error for calculating the confidence interval. So I'm going to take you over here. I'm going to stop again. And I want to take you over there. We're going to take the square root of P times 1 minus P divided by N. Make sure you get these parentheses on correctly so that you get the square root function to operate effectively. So let's go do that on our P value, and that'll give us the standard error for P. And again, the purpose of that is eventually we're going to be calculating a margin of error. Okay, so that was the standard error for X, right? Now the standard error for P is that kooky formula there, equals square root, open parentheses, whatever P you got, P times, open parentheses, 1 minus P, close parentheses, divide by 30, N. You'll be dividing by 50 when you do your homework. And then close that up. And that should do it. Yeah. All right. So that's going to be the standard error for P. And again, we got one more step in order to be able to use those to then build the confidence interval. That's the next part. So this is all you have to be able to do for part 3 of the lesson. So one more time, this is S divided by the square root of the sample size, which is 30 in my case. You're going to have 50 in there. And this one is this kind of kooky looking formula, square root of P times 1 minus P over 30. Again, you're going to have 50 in there. Okay, let's go back and finish it up. Okay, we're on the last part. So this is where we get to building the confidence interval. I'm going to show you a couple ways to do it. One is using Excel, using the data analysis tool in Excel, which is really a wonderful tool. It actually will give you everything we've calculated so far. So you don't have to do all those hard calculations after all. But it's not real good at doing the P calculations. It only does the quantitative variables. So it's a little bit limited. Therefore, we need to know the long way as well. So I'm going to do it both ways so you can see that. So like I said, we're going to get a confidence interval around the mean. And we're going to get a confidence interval around this population proportion. So let's do that. Okay, as I said, you're going to take those point estimators that you have, and you're going to subtract or add, we're going to do both. We're going to do both. The margin of error, the confidence interval is what we're after here. And those figures we just calculated, those standard error figures, are part of calculating this margin of error. So we need to build one more step out of this. And we can also use Excel. So let's talk about the Excel for a second. So using Excel, it's the data analysis feature, which we have used in this class before, if you remember. When we did the histograms, I had you go in there. So if you, on your Excel program, if you're in Windows, you might have to add that feature in. Hopefully you can get it. I'm hoping you'll have that at home. If not, just reach out and let me know. I'll help you through it. So you go into data, and then you might have to go and add it. So if you remember, you go to File, and you go to Options, and then you go to Excel add-ins, and you say Go, and then you got to pick Data Analysis Tool Pack. So that's the one that you're going to need in order to be able to do this. And it's the same one we used before. It's just that we're going to be looking at selecting the descriptive statistics from that list where you selected histogram before. And when you do use this feature, it gives you a 95% confidence interval. Okay, so we're going to be using that because that's what it defaults to. Okay, so you take the point estimate that we calculated, which was either mean, the mean, or P, we're going to do both, and you add or subtract, like I said, that margin of error, that confidence interval that you generate. All right, so let me hop over to Excel and show you how to use that feature. All right, so you go to data. I've already got mine ready to go, so data analysis. And this is the same group of things that we looked at before. There's your histogram down there that we've done before. This time you're going to be picking descriptive statistics. Say, okay. And then here you got to highlight what you want for data, and that's the annual salary. Remember I had mentioned to you earlier that this shortcut, which is really wonderful, let me pull that up. I didn't really want it down there. I'll just cut that and pull it up. I got to go back in there and show you how to do that because it went too fast. I shouldn't talk at the same time as I'm trying to use the function. Let me show you again. Descriptive statistics. You got to highlight the data you want. So again, just delete that and highlight what you want. Highlight that. Then come back here. Okay, it is grouped by column, so that defaults, that's fine. You got to tell it where you want it to go. Let's fix that. So let's say we want it to go right there. That's fine. All right, now make sure both of these are picked, and it'll give you that option. It'll probably default to 95 because that's what it defaults to. Just make sure both of these are clicked, and then you say okay. All right, and that's, look how cool this is. What do you got here? Okay, let me get rid of this one. Same thing. I just want you to see it here. All right, so this is the same exact mean that I got earlier. See, these are the same. So that's a super nice shortcut. You don't have to go through and do each one of these all by themselves. Here's your standard deviation, standard deviation. Here's your standard error, right? Right there. This also is cool. You get the count. So it tells you how many data points you got. And it gives you sum. It gives you min and max, which are awesome to have. So min in this annual salary range. Notice it doesn't give you anything about age. We didn't highlight age, but it won't work on that because those are categorical data points and not quantitative. All right, so here's the thing that's new for us. I'll highlight that in a different color. That's the confidence interval, and that's ready to go. So you don't need to do anything more to it other than to add and subtract. Remember, you take the point estimate, which is the mean, and you first subtract to get the low, and then the same thing equals the point estimate, and now this time add the confidence. So what that's telling you is that you would expect, without having to do it as a shortcut, you would expect that 95% of the time, if you ran that sample, you would expect, if you did it over and over and over and over again, 95% of the time, that mean value would fall between these two data points. And that's a fairly precise number, right? It's not super wide. So I'd be real happy with that. It's giving me a really good result. Now, if I used a bigger sample, so when you get to doing yours for homework, you're going to do a sample size of 50. You're going to notice your standard error is smaller than mine because the bigger your sample size, the smaller your standard error. And the smaller your standard error, the smaller your confidence level in terms of the amount. Okay, it's still a 95% confidence level. But the dollar amount here will go down, which will make this even tighter, right? So the spread in these numbers won't be as big as this is, because this is based on just a sample of 30. And I asked you in your homework to do a standard error for 30, 50, and 100. So make sure you do all three. I just want you to see it come down. All right, so that's really everything that you have to do this week right there. So I want to also do these p-value and show you how to do this calculation kind of the long way using a neat little Excel function that gives you, it's called the t-stat, and you multiply the t-stat times the mean. So it doesn't, it's not as easy as using this where you can just add and subtract it. You got to do one more step to get that answer. So it's a neat little function. I'm going to go grab it because I can't remember the exact, it's right here. There it is. I'm going to use that. Let me go to my sheet. Right. What this is a t-stat for a two-tailed test. So you type equals t dot inv, there it is. Grab that one. All right, so here, it's a 95% confidence interval. The probability you put in there is 0.05, which is your significant level, right? So that has to total 100. 5% and 95 is 100%. So if this was a 90% confidence interval, then that would be 10%, or 0.1. If this was a 99% confidence interval, this would be 0.01 or 1%. All right, then the degrees of freedom that you use there is 1 minus the sample size. So my sample size is 30, so mine's going to be 29. All right, so then you take that t-value, and you multiply times the standard error. And that's how you get, look, that's how you get the confidence interval, right? So that's why you want to try to get this down if you can, because it'll shrink this up. It's actually multiplying times this t-value. So that's how you go about getting the confidence interval for the mean of the annual salary. And we can also do the same sort of thing with this p-value. So here was our p-value and our standard error for p. So for that, we use, if you remember, a z-score. So a z-score for a 95% confidence interval is 1.96 at a 95% confidence level. So z equals 1.96. So we take 1.96 times the standard error for p, and that right there is the confidence interval. So to get the low and the high, take the p-value, which is the mean p, and you subtract that, and then you take the p-value and you add that. Okay, so there is no table like this that you can do for the p-value, the proportion, because it's categorical data. So you're going to have to do that the old-fashioned way. So you take 196 times the standard error of p, that gives you the t statistic, kind of like this. So it's the equivalent to this. Okay, that's 196 is equivalent to this. And then you multiply that times the standard error, right, to get this, the confidence interval. And then you use this to get your spread. All right, so that's the whole problem right there. When you do it for homework, let's just take a quick peek at the homework. You're going to do your 50 sample, right? You're going to do the mean, the standard deviation .s, and the count of yeses for part 1 and 2. For part 3, you're going to add in the standard error for x and the standard error for p. Okay. For part 4, you're going to do the table, the descriptive statistics on the annual salary, okay? This doesn't need to be there, it was just an extra I did. So you're going to do this part, and there's your confidence interval, which you can use to get these high and low values, subtracting and adding. Or you can use this function that we just looked at 5%, 49, because you're going to do a 50 size, sample size. And then you multiply that figure times the standard error to get the confidence interval, which is the same as this. Okay, for the p, you got to do it the old-fashioned way. Use 196, that's the z-score, 196. And then you multiply that times the standard error for b, and then you use that to figure out the confidence interval at 95% for the p-value. So that's what you're doing for homework. You also have one extra one that's a bond. I thought was cool. These are all quantitative values, so you don't have to do any p-values there. You're going to do 2 descriptive tables for that, right? And you'll watch the video for that if you need to. You're going to do the confidence interval using the old-fashioned way. And then there's an extra video. Notice I gave you an extra video that has the calculations for getting these numbers. I threw that on afterwards because I did want you to be able to do it manually. All right, so that's pretty much. Let's go back to our slides. All right, so let me just walk you through some of this. This was another example that was in your book. There were 70 households. This is the amount of credit card debt they had. Because it's a quantitative variable, you're able to use that function in Excel and get the confidence interval using that right there and the point estimate, the mean, just like we did a few seconds ago. So it was another example of how to do that. It's kind of cool. This is me talking you through how to use that Excel function and how to deal with the degrees of freedom, right? And how to input that. Let me explain right here using this formula. So you need the t statistic, which is what you use that function in Excel to get, and then you multiply that times the standard error, and then you take that right there is a confidence, that whole piece. And you add and subtract from the point estimate, the mean, to get the confidence interval. Okay. And then this is for the proportion one. You have to use a z-score. The z-score is 1.96 for a confidence interval of 95%. And then this is the standard error calculation. So you multiply those two pieces together. That gives you your confidence interval. And you add and subtract it from the point estimate for the proportion of yeses to get your answer. There's those values. So if we were doing a 90% confidence interval, we would use as a z-score 1.645, but because we are doing a 95, we're going to use 1.96. So that's the one we're using right there. Okay. And then talking about that level of significance, when you use the Excel function, that TINV.2T, two-tailed test, the level of significance is 1 minus the confidence coefficient, which is in our case the 95%. So 1 minus 95.95 is 0.05. So we'd say a 5% level of significance. All right, and we already looked at those assignments. That brings us to the end. So I hope that is a decent recording. The other one, when I watched it, was all broken up because we had all those lags. Remember when I was trying to load the data? The whole internet was lagging. So hopefully I got this one done in a little shorter time and it worked out better. So I'll stop the video now and post it for you to watch later.